Assalamu alaikum. How are you? Are you fine? I apologize for changing the time of the class. Unfortunately, this evening the internet was very bad in our city, and I could not define any webinar via the online LMS system. So I appreciate you for your attendance to the class at this time, and excuse me. Let me share my screen and start my class. I hope your friends can attend to this class. Can you hear me? Yes. Okay. Let me take a record for who could not attend to this class. Record meeting. Okay. As you remember, in the last lecture, I talked about the input space partitioning techniques to design test sets from chapter 6 of the Introduction to Software Testing textbook. Probably you know what's the input space partitioning, or ISP, in this context. As I told, this technique could be used in unit testing, integration testing, and system testing equally. This technique is easy to be automated, and no need could be applied with no automation, and there is no need to know about the implementation of the system, or to have the source code of the system. These techniques could be used in black box testing, as I told before. Let me to have a quick overview of previous concepts to remember. We have defined the input domain as all possible inputs of a program, and input parameters which define the scope of the input domain. From a file or global variables or other user inputs, all of these constitute the input parameters of a typical program. And we try to partition input domains into some blocks or regions. Could have some characteristics, and each characteristic can partition our input domain into some blocks. So we officially define the domain as D, and partition scheme Q of D, which partitions the domain D into a set of disjoint blocks. Each pair of these blocks have no any values in common, which defines disjointness of a pair of blocks. So the blocks must be pairwise disjointness in this partitioning technique, and together the blocks cover the domain. All blocks together should constitute the domain completely. Suppose we have a domain D as this rectangle, and as you see, this domain is partitioned to 3 blocks. Each pair of these blocks have no any value in common, and the intersection of all pairs of these blocks are empty. So these blocks have this disjointness property, and union of these blocks make the domain D. So these two properties should be held for all partitioning or all applying all characteristics in these techniques. How we could use these partitions? We can choose a value from each block to test the functionality of our program, and we could forming the partitions by some characteristics of our input parameters. So the first task, the first responsibility of the test engineer is to find characteristics of input parameters, such as case of letters, relationship to special values such as 0 for integer values, integer parameters, and some other semantics of our input parameters. The second responsibility is partition each characteristic into blocks, and form a set of blocks. As I told, each pair of them should be disjoint, and all of them constitute the universal domain D. And choose test cases or test sets by combining values from different blocks. For example, some characteristics are illustrated in this slide. Whether an object X is null or not could be one notable characteristics informing our partitions or our blocks of domain, or some other characteristics you have seen before. Another point is that how we could choose partitions. Defining partitions is not hard, but as I said, it could be get wrong. For example, the order of elements in an input list could trick us, because when we consider the characteristic of the order of elements, we could simply partition the domain into 3 blocks. The blocks B1 for sorted ascending in a sorted list in ascending order. The block B2 consists of includes all lists that are sorted in descending order, and block 3, the third block, includes all lists that have an arbitrary order. As you know, for lists of length 1 or 0, these blocks have some lists in common. They are overlapped with each other. Okay, so the disjointness property is not held in this partitioning, and it's wrong. I told about these boxes before. So in these cases, we could simply consider each characteristics in isolation. For example, the characteristic C1 lists which partition lists which are in sorted ascending order. By these characteristics, we could partition our domain into 2 blocks, 2 disjointness blocks. The block B1 for characteristic C1 is all lists which are sorted ascending, and block B2 is all lists, includes all lists which are not sorted in ascending order. Okay, the property is true for block B1, but it is false for block B2. So obviously these 2 blocks could not be overlapped with each other, and could not have some sets in common. And in the second characteristic, the list F sorted in descending order, we have to partition again which are disjoint, and the block B1 for characteristic C2 is the set of all lists that are sorted in descending order, and the block B2 includes all sets that are not sorted in descending order. So to treat with this tricky point, we simply can consider each characteristic in isolation, but in the at first we consider the order of list as one characteristic, but in this step, in the second decision, we consider 2 isolated characteristics for partitioning. as you know, as I said before, we could have several characteristics to partition the domain and choose our test sets for each partitioning. So the properties, we talk about the properties of partitions, and I think there is no necessary things to talk about, and we have identified in previous lecture 5 steps in ISP or input space partitioning, or in domain modeling. As you know, in the first step we should identify the testable functions from our program, from the program or under test, and as I said, all individual methods are testable functions. Methods in a class often share some characteristics of the class because they could use, all of them can use some properties of the class or some fields of the class in common. Another property should be considered in this step is that programs have more complicated characteristics. Modeling documents such as UML can be used to design characteristics. This says that several characteristics could be considered or should be considered in domain space partitioning when we use in black box testing. And for system testing. In step 2, we just find all parameters. To find all parameters, the parameters, the explicit parameters of each testable function or each method of our program should be considered. All shared variables or shared state of the method or of the program should be considered as input. Parameters to methods and state variables of each component could be should be considered as input parameters, or all inputs and in file and databases which are used in the system should be also considered as our parameters in domain modeling. In step 3, we should model the input domain, and I've talked about this step. As you know, this is the most creative design step in these techniques, and the tester should try a lot to design more effective tests. In step 4, in which I'll talk about the step 4 in next session, it's about selecting one coverage criteria in these techniques to apply these techniques to design our test cases, and this could be considered for next session. And finally, we could refine the combinations of blocks to design the final test cases. Until now, if you have any question, you could ask your questions. This is just the point. I finished my lecture in previous session. Define the type of each block. In this session, we start for this session. We talk about just about two approaches of input domain modeling. We have two input approaches to modeling regarding to the input domain. The first approach is interface-based approach, and the second one is functionality-based approach. I will delve in these two approaches in this session. This just zero element, and the self block consists of values which are greater than 0. So in this approach, we treat mechanically with our input parameters and consider each of input parameters in isolation. So this is the simplest application method for input domain modeling and can be partially automated in some situations because there is no need to inference about some concepts. There is no need to analyze the semantic of input to consider the relationship of input parameters and density or the effect of each parameter to other parameters. So this approach could be done easy and could be automated and could be done mechanically. But in functionality-based approach, we need to know more about our parameters, and in this approach, we should consider some characteristics about the behavioral view of the program. We should know the preconditions and postconditions of each method of the program, and we should know about what is each input parameters and what is its functionality or their functionalities. Okay, and what about the relationship of a method parameters, the relationship between each method parameters. Okay, so this is more complicated. This approach could be more complicated than the first approach, because in this approach we should analyze the semantic of each input parameter, the relationship between parameters, the functionality of each method, the functionality of a program, and so on. So this approach is harder to develop and requires more design effort for test engineers. It may result in better tests. It's trivial when we do more effort we expect better results. So there is no problem in this sense, and this approach could lead to a better test cases or fewer tests that are as effective. Okay, this is not enough about this approach. We should with more about these approaches in next slides and explain them by using some illustrative examples. So let's go to the next slides and talk with more details about this approach. In interface-based approach, as you see in this slide, we could mechanically consider each parameter in isolation, as I told in previous slide. This is an easy modeling technique and relies mostly on syntax. The syntax we in doing this approach in automation, we could review our definition or interfaces of our methods and consider just the syntax of our methods. The syntax of our methods could be defined by their return values and their input parameters. And there is no need knowledge about the functionality of each method. We just treat mechanically with this syntax, with this definition of our methods. Some domain and semantic information won't be used in this approach. There is no need to knowledge about the semantics of our parameters or domain of the program. But one of the disadvantages of this approach is that it could lead to an incomplete model, incomplete partitioning, because we have not considered the semantics of our parameters. And in this approach, we usually ignore relationship among parameters, because there is no knowledge about the semantic of parameter or their relationships. Let me ask this comment: if it is hard to developers, how is used? It's hard for automation. It's harder for automation, not for developers. I thought about the hardness of designing automated tools for designing test cases, but it could be easy for developers, as I will see soon by some examples. We will conclude that it could be easy for developers, but it could be hard for automation, because when we consider the semantic of input parameters, automation tools could not consider the semantics easily. Okay. So for example, we consider a simple example from Jeff Offwood website. Let me to go to this page. Consider we have a method. Which keep the length of sides of any triangle, and it was expected to detect the type of the triangle. As you know, we could have three type of triangles, which consists of the scalene triangle, the isosceles triangle, and equilateral triangle. In this triangle, three sides of the triangle should be equal. In this triangle, in this type of triangle, two sides should be equal. And in the scalene triangles, there is no relationship, any meaning for triangles. So there is three types of triangles, and we want to design a method to detect the type of any triangle. And we could consider simply an invalid triangle. Maybe our input could not form any triangle. For example, if you consider a triangle with a side 0, a side 1, and a side 2, you know that we have no triangle with a side of length 0. Okay, so it's possible to feed the method with invalid parameters. So altogether we have four types of triangles: scalene, isosceles, and equilateral triangle, and the last type is invalid triangle. So suppose we have a program which take the length of three sides of each triangle, which receive the length of each sides of the triangle, and tell us about the type of the triangle. For example, in a typical implementation of this functionality, we could define a class such as triangle type. Okay, and in this class we should define a method to detect the type of triangle. In this method, we should send three parameters. The first parameter is the length of side 1, the second is the length of side 2, and the third one is the length of the third side of a triangle. Okay, all of these slides is considered as integer value. We simply define these sides as integer lengths. Okay. When we have an invalid triangle, when these sides could be defined as invalid value. For example, when we set these parameters, each of these parameters to value such that is less than 0, we have an invalid triangle, because there is no triangle with a negative length for each side of the triangle. Okay, so in the first step we should check if this combination of input parameters is feasible or not. When each of these parameters is less than 0, we could not define a valid triangle by these parameter values. So in the first step we check the values of each parameter to be greater than 0. If not, we simply return the invalid type. And in the second step we check the triangle inequality. When the sum of the lengths of two sides is less than the length of the third side, this combination could not define a valid triangle. In this step we also check another type of invalid triangles. Okay, invalid parameters as sides of a triangle. Okay, and in the third step we check about the equilateral triangles. When all sides of triangle have the same length, we have an equilateral triangle. So if side S1 equals with S2 and S2 equals with S3, all sides have the same value, all parameters have the same value, we could return equilateral triangle. And in the fourth step we try to check if the triangle, if the input sides make isosceles triangle or not. If two of these sides, these three sides be equal, we have an isosceles triangle. Okay, if none of these conditions is true, we could return scaling triangle. Okay, this is the program for detecting the type of triangle, and we consider this as our example to design or to model our input domain by the two approaches, interface-based approach or a functionality-based approach. We consider this example for both of approaches to explain with more detail. So consider method triangle from class triangle type on the book website. As you see, we have defined the enumeration type triangle as 4 types. You have seen the scaling triangle, isosceles triangle, equilateral triangle, or invalid triangle. And you know each of these types. In this type, it may be we have some sides of length negative, or the sum of two sides could be less than the self side. In the equilateral triangle, all sides of the triangle should be same, should have same value. Okay. Or in the isosceles triangle, two of sides are the same. And in a scaling triangle, there is no relationship between the equality relationship between each pair of sides of triangle. Okay. So we have defined a method triangle and their sides as input parameters. Let me use interface based approach. As I said, we should treat mechanically with these parameters. This means that we consider each parameter in isolation. So the only characteristics we could use to partition the domain of these parameters, these integer parameters, is the relationship of values with 0. So for partitioning in this approach, we could just consider this characteristic, the relationship of side with 0. So for this parameter, we have 3 blocks, and so for this parameter and this parameter. Okay, we have 3 blocks: negative, positive, and 0. Okay. Excuse me, let me consider all partitions could be considered in this approach. So as you know, 3 blocks could be considered for each parameter. So altogether, the all blocks we should consider to test this method is 3 cross product with the blocks, the total blocks for this parameter. It's also 3, and this is 3. So 3 times 3 times 3 blocks could be defined to choose our input values. Okay. But when we use functionality-based approach, we should consider the relationship, the semantic, the meaning of each parameter, and the functionality of the method. As you know, the functionality of this method is to detect the type of the triangle. So the prominent characteristic in functionality-based approach is the type of the triangle. And when we know the functionality, design different test cases. We could design a test case in which the input triangle is scaling. We could define one test case for invalid triangle. We could define one test case for equilateral triangle. So we could simply say this approach is blindly testing. We don't consider any semantic about the input parameters or about the functionality of the method. But in functionality phase, we consider all of these possibilities. We identify characteristics that correspond to the intended functionality. As you know, we have defined this method to detect the type of a triangle. But in practice, the definition of triangles, the principle of triangles are not considered at all. And I don't know, we don't know these parameters. Which are these parameters? What is these parameters? Okay. So in this approach, in the functionality-based approach, as I want to consider some more semantics, more functionalities, we can incorporate domain experts, and we should have some semantic knowledge. We can use the relationship of the input parameters, and we could model the domain based on requirement document, based on the specification of the software product or of the, and necessarily there is no implementation access. Okay. In this approach, the same parameter may appear characteristic. As you know, for checking the equilateral triangle, we should either each pairs of our input values in test cases. To test cases. Okay. Excuse me. Again, we consider the method triangle in triangle type class. As you know, we have three parameters that are the sides of the only characteristic in this approach is the type of triangle, and you know we have four types of triangle. A good test set in this approach is a test set that consists at least tests. Test case which is scaling triangle, one for isosceles triangle, one for equilateral triangle, and one invariant combination. So we remember this step, this up, what are the duty of testers in each the step we should this is trivial for all programs. In step two, we should differ of bar and shells. For character values, we consider the case of letters. For Boolean parameters, we consider the true or false parameters. So candidates for characteristics in interface-based approach, conditionality-based application of our method or relationships among input parameters or input variables, the relationship of variables with special values, as I said, in interface-based. In this step, we should not necessarily use the program source. This means we have not access to the body of our methods, but we have the definition, the interface of our methods. We need to use the definitions of our interfaces or of class interfaces. But there is no need to any details of the body of each method. So in this chapter, we just use the definition of interfaces and the functionality, the description of the functionality of program methods. This item said that it's better to have more characteristics with few blacks, but when we have more characteristics with more blacks, we should define more tests, because we should define in the best situation all combinations of all blacks, and it could be impossible for big programs. And in the next session, we will talk about some coverage criteria to limit the test cases to fewer tests. Okay. As another example, please note to this simple method which tries to find an element from a list. We search an object into a list, and this simple element return a Boolean value, which if the list or element is null, it should throw null pointer exception, as you have seen before in previous chapters. Else return true if element is in the list. If we have an occurrence of the element in the list, we should return true, but otherwise we should return false. This is a simple description for this simple method. This is all information we need about one method. We need to design test case in this chapter for this simple method, and there is no the body of this method. There is no need to have the source code. Okay, we could use both approaches, interface approach and functionality based approach, according to this given knowledge. Okay, let me see. In interface approach, we consider each of these two parameters in isolation. For example, we consider the list parameter in isolation and partition the domain of the lists in isolation. For example, we could define some partitions for lists. We could define a block which consists of a list, a null list, or a list with 0 empty list, or we could define a block with lists with more than one element. Okay, so we consider several characteristics. We could consider several characteristics for this parameter. The first characteristic is the null characteristic. When we use these characteristics for partition the domain, we could have just two blocks by this characteristic. The block 1 define a simple null list, a set with a 1 instance of lists, which is a null list. But block 2 could have several instances of lists which are not null. So by this characteristic, we could partition our domain into two blocks. The second characteristics could be considered. The second characteristic that could be considered in this approach is the empty characteristic. We could define an empty list and a non-empty list. If this characteristic is true, we have simple an empty list. It's just one empty list, but could have many instances of any arbitrary list with any length, any number of objects. So in this example, we just consider the first parameter in our partitioning. Also, we could consider the second parameter in isolation. For example, the second parameter also could be null. If the second parameter is an integer value, we could consider the relationship of this parameter with 0 or any other data types in any other data types as we can define. So in interface-based approach, we just consider characteristics which are special to any parameter in isolation. But in functionality-based approach, we consider the functionality of the method. The functionality of the method is defined by the preconditions, by postconditions, by the relationship of its parameters, okay, by the semantic of its parameters, and so on. So in this approach, we have two parameters, list and element, but as we know, the functionality of this method is to search an element within a list. As we know this functionality, our view is different from previous approach. In the previous approach, we have no knowledge about this method. We could not use these descriptions of the method. But in functionality based, we zoom in these descriptions, and we should consider the functionality of the method. So in this approach, our characteristics could be as these characteristics. The first characteristic could be the number of occurrences of an element in the list. The occurrences of an element in which an element is not located in the list. Or could be one when we have only one occurrences of the element in the list, and more than one for several occurrences element in the list. So this could be a notable characteristics when we know about the functionality of the method. But when we don't know about this method, we don't know about the relationship of these two parameters. So if we know the functionality, we could consider some more meaningful characteristics to partition our domain, to model our domain. There are some other characteristics could be considered in tests of this method. Another characteristics could be this: the element we search in the list could occur in first position of the list or not. As you know, as you have seen in chapter 2, one fault could be in the for loop of our search algorithm, of our sequential search algorithm, as you have seen in a simple example in chapter 2. We start to scan our elements from position 1, not position 0 for Java programs. So when we know that this method is a search method, we should have to tell the boundary positions, such as the 0 of the element in the list. We should check the first position of the list, first index of the list, and we should check the last index of the list. There are two critical positions in searching methods: first position and last position. So according to these characteristics, we have two blocks for each characteristic. And this characteristic is considered for partitioning. We have two partitions. The partitions include a non-empty list. Non-empty list, when this characteristic is true, we should feed this function by a non-empty list in which the element is located in the first position, in the 0 index of the list. And when this characteristic is considered as false, we should define input parameters, we should define a test case in which we have a non-empty list, but the element may be occurrence in other positions, in other locations, not location. Third characteristic, the position of the element is also matter. When this characteristic is true, the element should be located in the last position with index n-1, in which n is the length of the list. And when this characteristic considered as false, we should provide a test case in which we have a non-empty list and the element be located in the last position. Okay, so these characteristics is completely different from these characteristics. These characteristics could not be considered in interface-based approach, because in interface approach we don't consider any knowledge about any semantics of the functionality of the method or the relationship of its parameters or the semantics of its parameters. So these characteristics could not be considered in this approach. This could be just considered in functionality based approach. So in the third step, of modeling the input domain, we should do the partitioning according to our code we have defined. We should partition our domain into blocks, and the values is very creative engineering step, because our partitions should be disjoint and all of them constitute the domain, our domain. And this step, more blocks means more tests, because we should test a value from each block to assert the correctness of the completeness of this. Okay. Partitioning often flows directly from the definition of characteristics. It's trivial. And both steps are done together, both steps and step 2, and should evaluate them separately. Sometimes fewer characteristics can be used with more blocks and vice versa. A trade-off between the number of characteristics the number of blocks. More characteristics means more tests, and more blocks also means more tests. So the number of tests that should be generated number. More tests, as you know, means more costs to testing, and sometimes it's impossible to programs. The strategies for identifying values, there are some characteristics, there are some strategies for identifying values of each blocks of our partitions. Could be include a valid value, invalid ones. For example, in a triangle example, we could define invalid values for sides of the triangle. Or in interface-based approach, we used a special value, a zero value as a special value. We could use this strategy. We could partition more some blocks. Some blocks could be partitioned with more details, more characteristics. And an important strategy could be this strategy. We could explore boundary values. As you have seen in previous slide, the boundary values for this functionality could be the location of our elements at first position or last position. So the boundary values are important values, and we should select them. We should test. And besides this, in special values or special boundary values, we should consider normal values, such as normal this with more than one element. Okay. Try balance the number of blocks in each characteristics, as I told before. Check the completeness and disjointness. These two characteristics, these two properties should be held in all modeling domains. Again, suppose the triangle method, and we want to generate test cases in both approaches. We have talked about the interface approach and in a functionality-based approach. As I said, the main characteristics for the triangle method, as you know, we have three sides in a triangle. We have three sides as the parameters of this method. The input parameters is side 1, side 2, and side 3. So in interface-based approach, the prominent characteristics, the important characteristic to partition the domain of each parameter is relationship to zero value. Okay, so the first parameter could have 3 blocks. The second one again have 3 blocks, and this so on for the third parameter. Okay, so altogether the maximum of block is equal to 27. Okay, so we could test the method, this method, with 27 different tests. All positive values set to be selected, and so with negative values. Some are not valid or invalid, because if any of have a negative or zero value, choose a negative or zero value, our test case define an invalid type of triangle. But in this method, we could not detect any other types of triangle. This means we could not detect scaling triangle, or could not detect before some test cases for equilateral triangle. Okay, so as the last point said, refining the characterization can lead to more tests, because we could consider more characteristics, but in this example there is no need, and we could consider more characterization. For example, we could consider some other special values, such as 1. We could consider another special value equal to 1. In addition to this special value, we could have another special value such as 1. But there is no need, as you will see in this slide. When we use more characteristics, more special values, we could have more tests. Okay, in this partitioning, suppose the relationship of special values 0 and 1 could be two characteristics, and the relationship to 0 negative values and values greater than 1 we tested out of our partitioning model. But this partitioning is integer values. For integer values, if we consider negative values, this partitioning is not valid, because we could not consider any value between 0 and 1. So we cannot consider any value in this scope between 0 and 1, which are less than 0 is considered in this block. The 0 value block, the 1 value is considered in this block, and the values greater than 1 are considered in block B1, but values between 0 and 1 are not considered in any of these blocks. So these blocks could not constitute our domain. real values. Partitions could be valid just for integer values. Please note to this item which says that complete only because inputs are integers. When the inputs are float or double values which have a floating point values, this partition is valid. Because the completeness property of the okay. So we could choose one value from each block to test the side parameter. Okay. For example, we choose a value 2 for this block from this block and value 0 and 1 for these two blocks and -1 for this block. Test boundary condition. These values are boundary values. The first value just less than the maximum value in this row is minus, and the minimal value in this block, the minimum value of this block, which is greater than 1, is 2. -1 is boundary values, and we should consider boundary values as I talked in important strategy in selecting input data. This is for inter-based. These considerations are hold for interface-based partitioning. But let's see the functionality-based modeling for triangle. The first two characteristics are based on syntax, parameters, and return type, and their types. The two characteristics should be considered about the syntax of the parameters of the method, and authorization could use the fact that the 3 integer represents a triangle. As we know, the functionality of this method, which is the detection of the type of the triangle, we have a mechanical characterization and or syntax-based characterizations, and we could have semantic characterization. Okay, in functionality-based modeling, we use this level of characterization. Partition our domain into 4 blocks. As I said, the blocks, 1 block for scaling triangles, 1 block for isosceles triangles, and 1 for equilateral triangles, and 1 for invalid triangles. Okay, so we should design 4 test cases according to this characteristic. This characteristic is named geometric classification. According to these characteristics, which we are considered according to the knowledge of the functionality of the method. Okay, so 4 test cases, at least we should define 4 test cases to test all blocks. Each value, each combination for each block should be tested. Again, please tell me if this partitioning is a valid partitioning. As you know, something is fishy in this partitioning. Could you tell me what is the fishing point? It is, excuse me, it's about equilateral and isosceles blocks. If these two blocks have shared some combinations, could have some values in common. Yes, they could have some values in common, because each equilateral triangle is also an isosceles triangle, because in this type of triangle all three sides are the same, have the same value. In this type of triangle we need just at least two sides have the same values. So when all three sides have the same value, we say that two of them have the same value. So all triangles are also isosceles triangles. So the property, the disjointness property, is not held for these two blocks. And the intersection of these two blocks is not empty. Okay. So we should revise this partitioning as this partitioning. Okay. In this partitioning, we consider 4 blocks of our input domain. The first one is the same as the previous partitioning. The third one and fourth is the same also, but the block B2 is redefined. The block B2 in this definition is all isosceles triangles, but not equivalent. Okay, is healed by this definition. Excuse me for your time. You have an exam. I will finish my speaking soon. Let me see next slides. This slide is about selecting values from each partition, from each block. It could be easily defined by boundary values, as I told, as a separate strategy in previous slide, or any arbitrary value from each block could be selected. For example, in functionality-based modeling in block 1, a test case is considered, such as this combination for block B2, B2, B3 or B4. Again, suitable values are selected randomly. There is a different partitioning in this slide, which consider the characteristics of each type of this partitioning. We have 8 blocks. We have 8 blocks because 2 blocks for each type of triangle is considered, and you know we have 4 types, so we have 8 blocks. And in this partitioning method, we should we should do 8 tests, each from a block. Okay. Okay, I will talk about step 4 in next session, in which we use some criteria in input domain partitioning. So let me finish this session, and you could have enough time for your exam. Have a nice day or good night. See you next session.